and good morning. My name is Daniel IZZAT with AWANG TANGAH, and my matrix number is 07DTP19F1008. Today I will present about abrasive jet machining. Okay then, this is process principle of abrasive jet machining. This machining process work on the basic principle of abrasive erosion. If a high velocity abrasive particle strike on a hard or brittle workpiece, it removes some metal at the striking surface. This metal removal process takes place due to a brittle fracture of metal and also due to a micro cutting by abrasive particle. This principal process of abrasive jet machining. Okay, so as you can see in the diagram, it shows how abrasive jet machining works. When an abrasive particle stream strike on a workpiece, it can remove some metal from it. Okay, the basic concept of abrasive jet machining is abrasive erosion or metal cutting by high velocity abrasive particle. Its working process can be easily summarized into following point. Okay, the first item that we see in the diagram is gas supply, filter, pressure regulator, vibrator, powder, supply and mixer, foot control valve, hand holder, nozzle, workpiece, hood and exhaust. Okay, now I will explain about abrasive jet machining working process. Okay, the first step is, first gas or air is compressed into gas compressor. Then the density and pressure of gas increase. Now this compressed gas sent to the filtration unit where dust and other suspended particle removed from it. This clean gas sent to the dryer which absorb moisture from it. It is used to avoid water or oil contamination of abrasive power. Now this clean and dry gas sent to the mixing chamber where abrasive feeder fit abrasive particle in it. The abrasive particle is about 50 micrometer grid size. Okay, then this high pressure abrasive carried gas to nozzle where its pressure energy convert into kinetic energy. The velocity of abrasive particle leaving the nozzle is about 200 meter per second. The standoff distance between workpiece and nozzle is about 2 mm. Now, this high velocity abrasive particle imping on workpiece. This high velocity abrasive particle remove the material by micro cutting action as well as brittle fracture of the work material. Okay, so that it's from me. Thank you.
Hello, my name is FARIZ bin SAFAR. My matrix number is 07DTP19F1024. So I want to continue the slide. Advantage. For advantage, first, cut virtually any material, pre-hardened steel, milled steel, copper, brass, aluminium, brittle material like glass, ceramic, quartz, and stone. Number 2, cut thin stuff or thick stuff. Number 3, make all sort of shape with only one tool. Number 4, no heat generate. Number 5, leave a certain smooth finish to reducing secondary operation. Number 6, clean cutting process without gas or oil. And number 7, modern system are now very easy to learn. Number 8, are very safe. And the last is machine stock of thin part all at once. Disadvantage. Okay, for disadvantage, first, limited number of material can be cut economically. While it is possible to cut tool steel and other hard material, the cutting rate has to be greatly reduced and the time to cut a part can be very long. Number 2, because of this, water jet cutting can be very costly and outweigh the advantage. And number 3, very thick part cannot be cut with water jet cutting and still hold dimension accuracy. If the part is too thick, the jet may dissipate some and cause it to cut on a diagonal or to have a wider cut at the bottom of the part than the top. And the last, it can also cause a rock wave pattern on the cut surface.
Alright, I will to present the application. The first point is pen removal, and second point cutting soft material, and then cutting frozen meat, and next textile leather industry, and next mass immunization, and then surgery, next pinning, and then cutting, and next pocket milling, and then lastly drilling. Alright, the diagram show the example.
My name is LASANG, matrix number 07DTP19F1038. So I would like to continue with the presentation. For discussions, analytically, modeling of abrasive jet machining involves the investigation on the effect of different types of process parameter. This study highlights different types of empirical equations, surface roughness, impingement angle, variation in material removing rate, MRR, curve geometry. The experiment shows that MRR is increased with increase in grain size and increase in nozzle diameter. The cushioning effect of the internal abrasive particles was explained. The effect of the process parameters like pressure, abrasive size, standoff distance on the work material, fiberglass are investigated for their effect on MRR. The material removal rate is directly proportional to the pressure. Material removal rate varies with the abrasive particle size. As the abrasive particle size increases, material removal rate also increases. So for the conclusion, AWGM is a comparatively recent machining process. It is mainly used for machining of high strength and difficult to cut materials due to its low cutting temperature, no heat damage to the surface, and low cutting forces. In recent years, the process has been applied to different materials such as ceramics, composites, titanium alloys, and even aphomous alloys. As a result of the present review, the following conclusion could be drawn. The abrasive water-jet material removal process is a complex erosion process where more than one mode contributes to erosion results. Two mechanisms have been identified for ductile material as the dominant modes for material removal: cutting wear mode and deformation wear mode. High surface quality was obtained with abrasive water-jet cutting by using high pressures and low traverse rates. The process does not generally affect the integrity of the surface. The depth of cut varies linearly with the abrasive flow rate and pressure. Low traverse rates are more efficient for deep cuts. The smaller the standoff distance, the deeper the cut. Next, it was shown that the maximum temperature occurs in the immediate vicinity of the cutting interface and decays rapidly thereafter with increasing distance from cutting interface. Lastly, the hardness and toughness of the abrasive water-jet nozzle material should both exceed certain threshold values for effective performance. Thank you.